On the mark, get set, go. Okay. So today we're talking about elasticities and taxes and how elasticities are connected to taxes. And see, believe it or not, we're talking about elastic bands, stretching and non-stretching, right? So, where do I click? Right here. So price elasticity of demand. There are several different kinds of elasticities. We're going to cover price elasticity of demand, of supply, cross price elasticity, as well as income elasticity. Why it is an interesting question? Well, because in from seller's perspective, it's an interesting question because they might be wondering, what if we increase our prices by 1%? How will our sales change? What if we reduce prices by 60%? How will our sales change? Will they change by a lot, by more than 60%, by less than 60%, or by very little? And elasticity allows us to answer that question. So the word elastic means responsive or non-responsive to price changes. So when demand is elastic, it is sensitive to changes in prices. So specifically, demand is elastic. If a price is increased by 1%, and the quantity by which the demand will decrease would be more than 1%. So in that case, demand is sensitive. And it's not sensitive or inelastic when we increase the price and it reduces by 1%, but it reduces the quantity by less than 1%. It'll become a little more clear as we keep talking. Oh, I did not do this animation. It just showed up. Okay, that's fine. So look at these two different demand curves. One is flat, one is steep. That's the difference. So in case of the blue curve, it's not a curve, it's like a line, but we call it a curve because it can be curvy as long as it's downward sloping. We're looking at a demand curve. So the curvy, goes up and down. Okay. So the blue curve, in both cases, price increases from $40 to $50. This could be price of a, say, a fancy hat, something like that. So at $40, 80 hats are sold. I'm looking at the blue curve, right? And the price goes up to $50. And the quantity demanded doesn't change much. It only decreases to 75 hats. So really, we have a pretty large increase in price, a very small increase in quantity in case of the blue curve. Now, if we look at the red curve, then the same increase in price causes a much larger decrease in quantity to 20 hats, from 80 to 20 hats. That's the hell of a lot of a decrease, right? As if a small change in price suddenly make all the buyers disappear. Why would the buyers disappear all of a sudden? Well, maybe they have other places where they can buy hats in this market. And in the case of the blue curve, maybe buyers don't have any other substitutes for those hats, and they really, really need those hats. Okay, so let's see. Oh, let's change animation here. I wasn't expecting it. So the flatter curve is more elastic. That's what we need to keep in mind. So usually flatter curve is more elastic, and we could see people are more sensitive to an increase in price or a decrease in price, whichever way it goes. Flat curve. So what are the reasons for why demand may be more elastic? So many more hats are available, many other hat substitutes are available. So many substitute goods are available in the market. People have longer period of time. Doesn't, I don't know if it applies to hats, but oftentimes to sunscreen. Say you're at a resort and you just need to get out and get into that water, but you forgot your sunscreen. So you go out and you buy a bottle of sunscreen for $15. I've seen that happen, right? Whereas if you were to wait and like search for it for a couple of days, you'd probably find it for $2 for the same container, right? So you're less price sensitive when you are on a rush schedule. When something is a large part of your budget, so a big purchase versus a small purchase, people are less sensitive to price changes when we're talking about small purchase. So whereas we're more sensitive and thoughtful and kind of more tend to search for better price when it's a larger share of our budget. So there's a small share of a budget. A good example would be salt, right? You need salt. You go to the top of the aisle and buy 80-cent kind of salt, even though you could have bought 30 cents again kind of salt, right? It's a small share of the budget. You don't care about 100%, over 100% change in price, really. One good is a luxury. Supposedly, you can argue that people are more sensitive to the price versus the necessity, which would be milk and bread. I'm not exactly sure about. So luxury and necessity are defined in terms of income elasticity, really. Maybe that's true, but I also find myself quite price sensitive with respect to necessities. Let's say when the bread price goes down by a lot, I might buy 2 loaves instead of one, or I might buy way more blueberries than usual when they are on a half price sale. So, but suppose that my behavior would be the same in terms of luxuries as well. So when something is super cheap, I might double up my purchases or even triple my purchases. So inelastic demand, the opposite reasons for inelastic demand. So when the product has no close substitutes, yeah, so we are paying a higher price. No, so we tend to buy it at a higher price or at a lower price and not reduce our buying behavior. So when it's a small part of our budget or when it's an addicting good, so such as this kind of drug in the picture. So addiction means people are less sensitive to the price change, and when you have a short period of time, so you don't have the time to find a substitute. The good is a necessity, like eggs, but again, I'm not exactly agreeing with a luxury necessity dilemma here. The broadly defined category of goods such as cars, food, and clothes have a less elastic demand compared to many varieties of, say, different foods or within foods. Okay, so we have noodles, we have pizza, we have everything, 100 other categories of food, and so for those categories, there are very many substitutes within each category, whereas there are no really substitutes for food. You need food no matter what. So yeah, but the broader defined category means lower elasticity of demand. So the formal definition of elasticity. So price elasticity of demand is a percentage change in quantity demanded in response to 1% change in price. And it's a number that can be computed. So, okay, that's wait till my silly animation plays out. Here it is. So price elasticity of demand is the percent change in quantity divided the percent change in price. That's how we find it. So in our old example with hats, the price increased from 40 to 50. And then in response to that, the quantity decreased from 80 to 20. We can find percent change in quantity, which is 20 minus 80 divided by 80. We're used to finding percent change by dividing it by the starting point, which is 80 in this case. The starting point in price is 40. But we're about to show that there's a problem with that, and this is going to be a reason for why we're going to be using midpoint formula. But let's just focus on this first and compute our elasticity number. This is our elasticity number, percent change in quantity. Looks like a scary formula, but it's not. It's just a notation, percent, and then a delta. The Greek letter delta is used to denote change. To percent change in quantity. Quantity decreased by 75% in this case. Price. So the change, 50 minus 40 divided by the starting value is 25% increase in price. So, and we get a number which is -3. So demand elasticity or price elasticity of demand is always a negative number. It's 100% of the time a negative number because demand curve is downward sloping. So it's just the law of demand, right? The highest the price, the lowest the quantity, and vice versa. So it's a negative number. So we even allowed to drop that negative sign, but I'll do that down the road. So we got 3, right? 3 kind of meaning that a 1% change in price reduces the quantity that people are willing to buy by 3%. And it's a very, very sensitive kind of demand. Now, let's look at the next move that we do here. Sorry about that animation, that unpredictable. So if the price, instead of going up, actually goes down from 50 to 40 and nothing else changes, then what changes is the starting value. We are dividing by, so in the denominator value. So instead of dividing by 80, we're now dividing by 20. Instead of dividing by 40, we're now dividing by 50 in the percent change in price. So we're getting different values. So now the quantity actually decreased by 300%. Increase, sorry about that. So by 300%, because 100% of 20 would be 40, right? That increase by 100%. And here the increase is 300%, 3 times of that. So 300%. And then the price decreased only by 20%. So we get a different value for elasticity if we're following this method. So 300 divided by 20, we get a -15. And that's different from -3. So which one is correct? you might ask. You might wonder, rightfully so. Well, really, both are correct, but at the same time, neither, because we need to come up with one number. Because in practical situation, a seller, which is a store, hat store, might just be wondering, what if the price changes between these two numbers, between 50 and 40? Is the demand price sensitive or not? Well, we'll lose a lot of customers. Either answer actually will suggest that yes, you'll lose a lot of customers. So, and maybe in some situations it does make sense to compute it the way we did for a decrease or an increase in price. But it is more common to use a midpoint formula. So instead of dividing it by 20 or 50, we'll divide it by 20 or 80. We'll divide it by the middle of the 20 and 18. So let's look at it. So 50 is the middle of 20 and 80, and 45 is the middle of 40 and 50. And that's why we will be dividing, we'll be using the middle of the number in the denominator. So, and as a result, we get something like 545 for the elasticity value using the midpoint formula. And in fact, there's one more different thing that we can do. Instead of treating it as a negative number, we can just take the absolute value of the elasticity, because we know as economists that it's always negative. Yet we just want to make our lives simple. But then don't get confused. It only applies to price elasticity of demand. Though we could say that it's okay, the elasticity is 5, but it's actually -5. But it's like the absolute value of elasticity is 5. But it's actually -5. But don't worry, it's still this. If it's price elasticity of demand and it's presented as positive, well, you know it's negative. Deep in your heart, you know it's a negative number. So that is what it is. Percent change in quantity divided by percent change in price. And now let's see how it applies. So, and how it can be interpreted. So in the table to the right, you see that different, it's been calculated approximately that goods like eggs, beef, gasoline, and even stationery, I'm surprised to see that, are having elastic demand. So you can increase on the price by 1%, and the sales only drop by 0.1% in case of eggs. And it's also true if the price increases by 10%, sales drop by only 1% in case of eggs. So that's what knowing the elasticity allows us to tell. So by how many percent will the sales of a good fall if the price increases by 1% or by 2% or by 10% or by any other amount of percent. So we call demand elastic if the number is higher than 1 in absolute value. No, again, notice these are presented as positive numbers, whereas you know that they're negative, right? So economists just want to make things more complicated than they are. So airline travel or airline travel is quite price elastic. So you can get people to buy more if you reduce the price. So if, let's say, price of airline travel goes down by 10%, by how many percent will sales increase in this case? Who can tell? Try, just say it in voice. Give it a guess. Well, I can't hear you. You might be muted if you're trying to say. So if the price of airline travel goes down by 10%, these numbers suggest that sales will increase by 24%. It's quite a bit. It's a large increase. Okay. So, oopsie. I was gonna go back a bit. Okay. So let's see for restaurant meals. If price decreases by 1%, by how many percent will sales increase? You want to say it? Say it.
23%.
That's if price decreases by 10%, then sales will increase by 23%. If price decreases by 1%, then by 2.3%, right? Any questions? Okay, what about if the price of gasoline goes up by 10%, by how many percent will sales decrease? You can say it. Okay, so the elasticity is 0.5. 5%, yes. The answer is 5%, yes. That's what it tells us. So notice, right? So in a 10% increase in price causes a 5% decrease in sales for the in case of gasoline. So it's not that price sensitive, but a 10% increase in price would reduce your purchases of restaurant meals by 23%. That's very price sensitive. So in that case, in the first case, your demand is inelastic. In the second case, it's elastic. Demand can also be unit elastic, which means the elasticity equals 1. So you can increase the price a little bit, decrease the price a little bit, and your quantity just adjusts. Also drops by 1% only as a result.
Can I ask a question?
Sure.
Can you go back one slide, please?
Go back.
Yeah, that one.
Yeah.
No, the one where it has the elasticity and inelasticity numbers in a table. Are those actual numbers or are those percentage points?
Okay, so elasticity is a number, but this number in a way shows a percent, but it's not a percentage point. No, it's a number.
Like when we say that it goes down, is it going down 23% or is it going down by a quantity demanded of 23? In the next slide, I think. Not this slide.
Okay, so
in this slide, like if you say restaurant meals go down by 23%, if the price goes up by 10%, or is it goes down by a quantity of 23?
No, elasticity is the percentage increase or decrease change in quantity in response to a 1% change in price.
Okay, thank you.
So it's kind of a number, but it means a percent. But we can't really put it 2.3% because elasticity is not a percent. But yeah, it kind of shows that percentage change. So you can think of it as a change in response to 1%. Yeah, percentage change in quantity in response to 1% change in price. Okay. I guess the reason is that if you say, well, elasticity increased by 1%, that would be different. Like what is 1% of 2.3%? Right? So that would be really confusing. That's why we just treat it as a number, but it does mean a percentage change. Okay, so let's do a couple more examples so that we remember it once and for all how to compute it and never make a mistake. If the price of a sushi roll changes between 10 and 20, the sales change from 10 to 15. What's the absolute value of the price elasticity of demand? And here you already don't know whether the price goes up or goes down. So you have to treat it as a midpoint formula. Use the midpoint formula. So we need to, well, in elastic, but we need to show it. So what do we have? Well, first we find the percent change in quantity, which is the difference between 15 and 10 divided by the midpoint. And then times 100%. So that is in percent, not in as a share, not in the share form, but in percent. So we find the 40% change in quantity. And then we'll find the percent change in price as the difference between the two, and divided it. And we find that it's 66.7%. And even at this point, we no longer even need to worry about whether it's negative or positive in case of price elasticity. And then we find the elasticity with a percentage in quantity divided by percentage in price, and we find that this is 0.6, which is less than 1, so it's inelastic demand. And you can even kind of gauge it, eyeball it, and say, oh, that curve is pretty steep. Yeah, it does look like an elastic demand, so probably did not make a mistake here. So that's what it is. Another example, in this case, the price again changes between 10 and 20, and the quantity between 90 and 100. And you apply the same formula. Oopsie, and I messed up with the slide again. Okay. Percent change in quantity divided by the midpoint. Difference divided by 95, which is the midpoint. Percent change in price. Difference divided by 15, and then you find the elasticity. And again, in this case, in one case, we look at it as a absolute value. In this case, this is not absolute value, but you can present it as absolute value as well and say, oh, it's even more inelastic, right? So the quantity didn't change at all, hardly barely changed, even though the price doubled, right? So must be some good that people really, really need badly or addicted to or have no substitute for. Okay. A couple of extreme cases. So in case when demand is virtually vertical, so is not elastic at all. So why would that be possible? So in this case, no matter how much the price changes, we will do that same amount, and at least within reasonable price values. People might not be sensitive to the price of things that they really, really need. Like if you're diabetic, you need insulin, or if you're really addicted to something, you need it so bad that you can pay double or triple the price. So that's perfectly inelastic demand, or zero elastic, yeah. And it could also be that demand is perfectly elastic. So in this case, the product is cost $5, and nobody will sell it to you for more than 5, and nobody will buy it for more than 5. So it's perfectly elastic demand. So then, slightly fictional case, extreme case, but we would like to look at extremes, right? So, but we already know that the flatter the curve, the higher is the elasticity, and then it becomes infinite when the curve is just like flat, horizontal. We know that demand curve cannot go beyond horizontal curve, right? Beyond, it cannot be upward sloping, right? So that's the limit of the demand curve. No matter how much output the producer makes, he sells it at the same price because the firm is perfectly competitive. But we'll talk about perfect competition in later chapters. So yeah, we'll expand on that a bit. That here we will assume that demand can only be that one price. So you're a very small part of the market. You cannot sell for more than $5. So bagel and coffee, for example, on the street, because on every corner there is some other food cart selling bagel and coffee, and it costs $5. So you cannot possibly sell it for 6 because people can go to the next corner and buy it for 5. So you have to sell it 5, and you won't sell it for less than 5 because you're not a fool, right? Why would you sell it for less? One more example. If the price of oil increases by 10%, and the quantity demanded falls by 5%, we need to find the price elasticity of demand. So that's straightforward. That percent change in quantity is 5. Percent change in price is 10. So one divided by the other, you find the absolute value, 0.5. That's the number we saw for gasoline, right? So very close. I think we are supposed to mute microphones, all of us. So if yours is not muted, mute it. It'll be easier to listen to the videos later this way. Okay, this is Brian's favorite question. The one from our practice quiz. So we have a college, a small liberal arts institution that decided to increase its offerings to students and did something, offered this and this and this. And even though tuition was raised by 29%, enrollment of freshman class rose by 37%. And so based on this information, what can we conclude about the elasticity of demand for tuition, for college education, for this specific college education? And the tough part here is that the numbers kind of at first sight suggest to you that, okay, well, maybe demand is price sensitive because the percent change in quantity is 37, and the percent change in price is 29. And so it's tempting to say, oh, this demand is elastic. But then you think twice, and you think again, what's wrong with the picture? Tuition increased. Isn't your enrollment supposed to go down with higher price? So it would be perfectly normal to say, for example, if prices increased by 29%, the enrollment declined by 2.9%. That would be more common to see something like this. Or maybe enrollment declined by 10%. It would still be pretty impressive, right? For a good to have that kind of inelastic demand that would be so wanted by potential consumers, customers, students in this case. that your price goes up by 29%, but your enrollment decreases only by less than 29%. But in this case, it's worse than that. I mean, it's better than that for the college. It doesn't decrease, it increases instead, which is a very, very, very unusual case. The case of insanely high demand, right? Insanely inelastic demand, the opposite of elastic, very, very not price sensitive, and kind of price sensitive in the wrong direction. So it's super inelastic demand if you think about that. But I guess this question is a little unusual. It's too unusual to be on the actual quiz. I'm pretty sure I did not put any questions like that on the actual quiz. And I will probably change it too, so because it does look like a case that could not exist, really. Too unrealistic. What do you think, people?
If I may, basically it's all about the price, the quantity rose rather than declined.
Yeah, and this sounds like something fishy about it. Like,
did you put rose in big black letters like that on the practice quiz? Because if you did, I totally missed it. I mean, it's a good thought-provoking question. I just wanted to make sure that I knew why I had it wrong. Basically, I was thinking about it a little bit dyslexically, if you want, but that happens.
It's like we all probably, like, at first read, we thought, oh, okay, it's super elastic because 1% change. Like, we kind of read it as if the freshman class decreased by 3.7%. That would be correct to say that demand is elastic, relatively elastic, or quite elastic, right? But it didn't decrease in this case. It rose, and it sounds like in this case we're dealing with a demand curve that's upward sloping, and it should not be upward sloping, right? So something is wrong with this college, or maybe something else happened to it. It's just not it's like people are willing to pay more for the same good. If the price goes up, it should not happen. I don't like this question anymore. So yeah.
Can I ask a question though?
Yeah.
Can't you think of a rise in quantity demanded as a negative decrease?
No.
Like, you could still use the same formula, but you have a double negative.
No, it should never happen. This question it's so unrealistic. It just assumes upward sloping demand curve, and I only realized it when I reread it and reread the answers, and I'm like, okay, Brian is a genius. He pointed out to a question that has a fundamental flaw. Yeah.
No, I was actually looking at the other clues too, be thinking, well, do these clues mean that the value of the tuition matched, I guess, the increase in cost? Therefore, does that make it inelastic? And again, I'm trying not to think it through too much. I'm guilty of that, of course, but so I'll leave it at that. Thank you for the explanation. It works.
Yeah. Yeah, I mean, every time if you find a question that sounds unusual or interesting or counterintuitive, let me know. Maybe I just I missed it somehow. Reading through many questions and picking out the questions. Just missed the interesting ones. Okay. Okay, let's think about elasticity and how it applies to MTA revenues. So what if, so subway rides, like, do we have elastic demand or inelastic demand for subway rides? So currently the price is what, $2.75 for a ride. So demand may be elastic. So suppose if it's elastic, then with elasticity of above 1.5 or 2 or 3, something like that, then what would happen is that a percent change in a fare, like a 10% raise in fare, the 10% is 27.5 cents, right? So something like to $3, almost 10%, right? Would reduce the number of people traveling or the number of trips taken per day by more than 10%, by say 15%. And then as a result, MTA revenues would fall, right? Because you increase the price and now we have by 10%, but now there are now there are 15% fewer people traveling. The revenues would fall. That would be true if there are a lot of substitutes for MTA for the subway. And it's probably not the case. That's my thought, and I wonder what do you think too, if that's the case. So maybe demand is actually not elastic. So maybe it's a number that's less than 1, so 0.3, 0.4, even 0.9. That would be inelastic demand. So let's say a 10% increase in fares to $3 would only reduce the number of trips taken per day by maybe 3%, maybe 2%. So maybe it's really inelastic. Maybe it won't even reduce much at all the number of trips taken. So, and in this case, let's think about an increase in fares to $3 would actually raise the revenues of MTA. And that's true if passengers have no other travel options. So what do you think? If subway fares were to increase to $3 or even $3.50, would that increase the revenues of MTA or reduce the revenues? So elastic or inelastic demand, most likely. Your opinion, anybody?
I
This is
think based on statistics available, ridership doesn't really change that much when they increase the fare, which is why people are always complaining about it, because honestly, MTA has a monopoly on public transportation. You got to do what you got to do. So I would think it was inelastic, and if it were inelastic, their revenue would go up because you either have the same amount of ridership or the decrease in ridership is so insignificant that the price change is making up for it.
Okay, others agree?
I agree. And back on your first couple slides before regarding to inelastic and elastics,
Yeah.
this is very specific. So it's only one single item, which is MTA. So by all means, if you're only looking at one segment, the demand will be literally inelastic. But if you're
Yeah.
looking at a bigger scope, like the whole transportations, then we're looking at the demand will be elastic. So in our case, we only have looking at one single specific case, which is the MTA subway. By all means, it's going to be inelastic.
Rudy, I think it's also the broader is the category, the more inelastic demand is. So let's keep that in mind too.
Ah,
Yeah, the broader is the category. So transportation, people need to move around. So their demand is pretty, no matter what, they have to move around. So are we not? But within little categories, if we have substitutes, it's just, you're right, they have a monopoly. So we don't really have much of a substitute. But if we had buses and very cheap taxis running around everywhere along the same routes, then people would be less sensitive. I mean, more sensitive to the price. So more elastic. Yeah, but in case of monopoly. But okay, so we're thinking about this difference in price of $2.75 versus $3, about 10% change in price. What if the price of MTA was $10? $10. So the $10 and we're thinking about moving it up to $11. So that's another 10% change in price. But we still have inelastic demand. Or would that, or we're talking about a slightly different segment of demand curve, which is a potential price, right? Why not? Why not make it $10 and then increase it to 11? Like, what do you think would be bigger reaction, smaller, from in terms of?
I think that would be a really large jump, and I think a lot of New Yorkers would consider other options, maybe getting a car instead, because going from 275 or 3 to 10 or 11, and that's just for one fare, and it usually commuting you have to do it every 5 days during normal times, not during the pandemic. I think people might consider getting cars and comparing the price of gas to the subway. So I think the revenue I think the revenue would decrease. The MTA revenue would decrease.
So
I think less people would take the subway if it was such a big jump, because you'd have to consider you that would, that $10 for one fare, and then you do it 20 days a week. I mean 20 days a month. That's quite high.
It all adds up, right? But also
Compared to
notice that
gas.
maybe in the very short run, people will still have to ride because they have to get to work. But over time, you don't buy a car in one day, right? But maybe in the course of a month, right? People might end up buying cars little by little. So the more time you have to adjust, the more price sensitive you will become. As we were just talking about, one of the factors of elastic demand. Yeah, maybe some people will take up walking, some people will take up biking more, or sharing rides somehow. Or maybe like a new app will develop over time, who wants to ride from this specific location at this time and then into Manhattan. Stuff like that.
Could they see like seasonal like elasticity and elasticities? Like in New York City specifically, we have different the weather changes seasonally. And like maybe during the summer I would bike. There's like 10,000 city bike things all over my neighborhood. But like I would never be able to buy a car no matter like how much I wanted that, because like where I work, all like there's only but so much parking, and if I would not ever be able to pull that off, I would just cry every morning thinking about getting to work. So, but maybe in the winter, I'm like, you know what, I'm gonna have to shell out these $10, and maybe the money I saved over the summer, so could they see like a seasonal where it would just go up and down depending on the surrounding circumstances and factors? Like, does something like that happen?
Yeah, right. So that's a good point, that the elasticity can change, right, depending on the time of the year, our reaction to it, right? Yeah, so in a business setting, you need to take into the account like things that make.
Would this question be speaking during this time of the pandemic, or during normal times, outside of the pandemic?
Guys, let's mute our mic when we are not talking, okay, so that we can all hear. Right. Yes, so there may be a different response, during different economic situations, like crisis versus non-crisis. Supposedly, MTA is heavily subsidized, so even a $3 fare would not cover the cost of their production of this providing the service. So I wonder what it is really, what cost of a ticket would cover their cost of production. Maybe regarding MTA, there may be better ideas on how to price it. So perhaps all New Yorkers residents could get some kind of resident cards and get subsidized fares, whereas foreigners and out of town people could be charged a different price. So there could be different pricing strategies there. But yeah, it's nice to understand that, yes, our elasticity can be affected by very many factors, and you just pointed them out. Perfect, let's move on. So what we just implied is that elasticity can be different along the demand curve. So when we talk about the price between $2 and $3, or the price between, in this case, so with the price of $1 and $2 versus $5 and $6 in this case. So let's look at the numbers. So I will show you. Let's put up the slide and show you that in case when the price is low, starting with $1 and $2, so that was our equivalent of $2.75 and $3 for the subway ride. We are talking about large quantities of ridership, and the expected change would be very small. So as if from 8 maybe million to 7 million, right, per week or so. So in response to a $1 change in price, which in this case is 100% change in price, right, from $1 to $2 in this example, and it results in a small percentage-wise change in quantity. So as we divide the small q by a large P, we get a number that's less than 1 in absolute value. And we can conclude that demand is inelastic. When we move to a larger price range, so again, so $1 change by between $5 and $6, it is a rather small percentage-wise change, right? From it's what, a $1 divided by 5, so that's a 20% change in price. So it's not 100% change in price anymore, right? A 20% change in price, and with a midpoint formula, will be even less than 20%. But we have a large percentage change in quantity from 2 to 3, and that's just divided by 2. It's a 50% change in quantity, slightly smaller with a midpoint formula, right? But let's say 50% divided by 20%, we have a higher than 1 elasticity value, so 2 in this case. So demand is elastic. So it depends really on the range of the demand curve we're talking about, and the range of the prices we're discussing. So yeah, everything is relative to how high is the price, how big is the change, what other factors might affect it, such as what weather and the timing of adjustment. And maybe your elasticity of demand for subway ride is different from mine. Maybe mine is less elastic because I live in New Jersey and I tend to take in subways infrequently. So really, once a month versus twice a month is not a big difference for me. It's not every day, right? Whereas you might be more elastic because it's a larger part of your budget compared to mine. So that's the same formula for elasticity. Let's look at total revenue as it relates to elasticity. Okay, so in this picture, we looked at a market where prices change from 80 cents to $1.25. So what could this be? This could be, a subway ride, not another subway ride. It could be a bus ride somewhere in a different town. A bus ride, so 80 cents, and increase to $1, then increase to $1.25. And then as a result of this price change, ridership declined from 155 to 130 and then to 100, maybe 100,000 or 100 per hour. So however it was measured, but we have the numbers and we're dealing with these numbers. What we want to compute here is total revenue, price times the quantities. So total revenue is basically the amount, dollar amount of your sales, total sales. So when the price was 80 cents each, 155 was sold, and that times that, 80 times 125, or 155, adds up to 1,000. Needs to be 120. Let's see, I messed up here. I added an extra zero, so it's 124. Okay, and then when it's a revenue, total revenue is a rectangle, gray rectangle in this case, and then when the price went up to $1, total revenue is computed as $1 times 130, so it should be $130 is the total revenue. Then the total revenue when the price is 125 is $125. See, what we see is there is a point on this demand curve where total revenue is at its higher point, and then it decreases as we move away from it in terms of price and in terms of quantity. Because when we are in point B and we're moving to point A, yeah, price increases, so per unit price goes up, but the amount of sales goes down by a larger amount. So when demand is elastic, an increase in price will cause significant reduction in the quantity demanded. So between A and B, demand is elastic. And we even saw it on the previous slide that on the higher portion of the demand curve, demand tends to be elastic, whereas on the lower portion of the demand curve, demand tends to be inelastic. So in case of inelastic demand, you know you're not going to lose your customers because they love you or they want your product or they're really not going to drop out of the market when the price increases, because we're starting out with relatively low price. So they really don't care as much when the price goes up from 80 cents to $1. So in elastic demand, you can increase the price. As a result, your total sales revenue will go up. Whereas if you continue to do so, you're moving into a more elastic part of the demand curve, where people do start caring about the price, and so they start dropping out of the market. So when you found yourself at a elastic part of the demand curve, it's actually better for you to reduce the price sometimes. And as you reduce the price, you may end up increasing your total revenue. That's the moral of the story. So you need to know how price sensitive your customers are, and then decide whether you want to be going up in price or going down in price in order to increase your sales revenue. So it matters whether you're starting out at point A or at point C. So in point C, for example, if you were to further drop the price, what's going to happen most likely? So you will reduce the price to 70 cents, but you're dealing with the inelastic part of the demand curve. So you're not going to gain a lot of buyers because they're not as price sensitive at that part. So you're probably not gonna increase your revenue. Now, revenue may not be your largest concern, but so you know that that's gonna happen to your revenue. It's probably gonna continue to go down. Whereas if you are at an optimal point somewhere, you can maximize your revenue by just making the right decisions about given your elasticity of demand. So this picture shows that. So what do we know here? We have a price and quantity, and we have a demand curve that varies from the price varies from $1 to 10. As a result, quantity demanded varies from 10 to $1. I think you asked a question. Somebody asked a question, and I will be able to read it in a sec. Oh, you're answering. Okay. Elastic overnight. So, okay. So what do we have? We compute total revenue price times quantity at each point. So we want to compute total revenue so that we could see along the entire range of the demand curve what happens to total revenue. So it's just another case. We kind of saw it, bits and pieces of it in the previous slides, but let's compute it. So for example, 1 times 9 gives us total revenue of 9. 2 times 8, 16, right? So you see the total revenue goes up as reflected here. So we plot total revenue, which we never did before. We really did not plot total revenue right next to the demand curve with the quantity axis being the same, but now we have total revenue on the vertical axis. And we're really not going to do it again, maybe once again or twice. So this is something we want to see, the relationship between the elastic segment of the demand curve and what happens to the revenue. It goes up. The higher is, no, the lower is the price in this case. We're reducing the price, but we are attracting more buyers. So our revenue keeps going up. Then at one point, we reduce and increase the price, right? So, but from 4 to 5, increase the quantity from 6 to 5, and our elasticity is 0. So we increase it by 1%, and the quantity went down by 1%. So we're kind of breaking even. And then after that, our revenue keeps going down because we're dealing with inelastic demand, so not price sensitive demand. So we can reduce demand, but we're not attracting a lot of buyers. So we would have better luck if our demand, so a slightly different result if our demand curve was to be curved, actually curved, like bowed in. So we would have a slightly different impact on revenue. It would not be going down just as steeply. But in this case, yeah, total revenue goes down. This is an example of unit elastic demand. So that market for tires. So demand is unit elastic, the quantity effect equals the price effect. So the increase in price exactly balances the reduction in the quantity demanded. So really, you're not being enticed by a 10% decrease in the price of tires is likely to increase demand, quantity demanded by only 10% or so. So that's been noticed about the tires market. Okay, now we've already answered this question, but we're returning to it. So the elasticity of demand for eggs has been estimated 0.1. And the demand elasticity for restaurant meals, 2.3. If producers of those goods raise their prices by 25%, what will happen to their total revenue? Okay, so no, we didn't answer this question. It's about total revenue. And in this case, it will be one answer in case of eggs, one answer in case of restaurant meals, different answer. Let's see. They produce now only for eggs first. So producers of eggs raise their prices by 25%. And we know that the demand for eggs is inelastic. So you might suspect, and rightfully so, that people will still be paying the price, right? They're not going to drop out of the market because the demand is inelastic. So yes, the revenue will increase. In this case, it will increase. But for restaurant meals, the story is different. We'll increase the price by 25%. And what it tells us is that 2.3 times 25% of people will drop out of the market. Your total revenue will actually go down. So that's true for in general for restaurant meals, but you could have different elasticities for different restaurants within it. So maybe some reputation of some restaurants make the demand for their meals way less elastic than for meals of other restaurants. So people just love a particular place and they have to go no matter what, whether the price is 25% high or not. Sometimes it happens, rarely. But so in this case, the answer would be the revenue will decrease for restaurant meals, not increase, decrease. Okay, I think that's another example. We're not going to completely do it. We'll still read it. It's similar to our questions. If price falls from 60 to 40, total revenue changes by, you would just compute total revenue changes, right? So total revenue of 60 times 6 would be, for the first point, right? 360 in this case. And then 40 times 12, and then you would compute that for 80, right? 360 or 80, that's the change in revenue. So that's 120. And you already kind of, by the first answer, you'd see, oh, I answered that question correctly. And it must be that demand is elastic. Okay, because the revenue increased, right? So you are reducing the price, revenue increase. So you must be on the elastic segment of the demand curve. Okay, when the patent expires and a brand name drug and 5 generic drugs come on the market, what happens to elasticity of demands for that drug? I guess for the generics, are people becoming more sensitive to the price? I think there's too many things at play here, but I suppose the expected answer would be that it rises. People become more price sensitive when you have more substitutes. So what happens in the real world? It depends really on the price, on the pricing the pharmaceutical companies engage sometimes in foul plays in terms of pricing of their drugs. So elasticity of supply is very similar idea as elasticity of demand, but applied to supply, and we need to expedite this because we have a lot to cover in no time. So when supply is elastic, it is reflected in a flatter supply curve. as you see, more sensitive to price. Same price change, but one curve is less sensitive than the other. For producers' perspective, it all depends on percent change in quantity supplied divided by percent change in price. So their behavior entirely depends by the availability of substitutes, of inputs in production. So just by how fast they can adjust to an increase in price. Can it be quick like that? Or do they need more time to design a new product or to put it in the market? So usually the very beginning, elasticity, for agricultural goods. Suppose, tomorrow people want more apples. Like, how can you grow more apples within 3 days? You can't, right? You can grow more apples within 5 years, right? If you plant new trees. But perhaps you could import more apples and all that. So it still needs time to adjust to this particular change. So it depends on different markets. And usually in the short run, quite an elastic supply, and the long run, more elastic supply. Okay. Extreme cases. Perfectly inelastic supply, such as land in Manhattan. Well, there's a certain amount, well, maybe it's not land in this case, housing, right? So for a certain period of time, for like say this month, February of 2021, the supply of housing may be inelastic and perfectly inelastic, kind of fixed at a certain level. Maybe it can change over time. Maybe the supply of housing is actually quite price sensitive. But the supply of land or Monet paintings, that's another example. Supply is fixed, right? So Monet has made a certain number of fixed number of paintings, right? And won't make any more. Right? Like whatever is available for sale is there no matter what the price is. And the opposite case, infinite. So notice that infinite supply and infinite demand look like flat curves, and zero elasticity supply and zero elasticity demand, they all look like vertical lines. So for perfectly elastic supply is an example of something very, very common that you can find everywhere, and it costs approximately the same price, but not quite the same price. As you noticed in previous lectures that you raised that question, why isn't it the same? That the price isn't the same for an identical product. And it all has to do with information. People, just not all consumers, know exactly that they can go around the corner and buy the same pizza for $12. So if they knew exactly, and maybe even if they knew exactly that they could buy the same pizza around the corner on the right or on the left within a short walk, 10-minute walk, maybe they still don't want to make that 10-minute walk. Maybe they would be willing to pay $13 for a pizza that's right next door to them. Could be for convenience. So that's why there might be tiny little local monopolies that can charge you a little bit higher price. But in the world of complete information and people not being tired and knowing everything about everybody, VIA would have the same prices and not valuing convenience, I guess. We would have the same prices for everything. So, okay, question. With midpoint formula, we need to compute price elasticity of supply. The price of milk increased from $1.90 to $2.10, and dairy farmers increased production from 9 to 11 tons. You apply the same idea as percent, you find the percent change in quantity supplied in this case, and divided by the percent change in price. So quantity, change from 9 to 11. So use the midpoint formula. And midpoint formula, so you divide by 10. The change divided by 10, you get the percent change in quantity. And a false what? Okay, and percent change in price divided by the midpoint. So now you have the elasticity. One divided by the other, you have a 2. So that's same idea applies. It's elastic, quite elastic, right? More than 1. It's always positive. So which of this curve is the more elastic? Assuming that S4 is not downward sloping, I think it looks flat. And if it's flat, like we know it has infinite elasticity. So S3 is pretty elastic too, right? So probably S4, we should say it's infinite, is higher than some kind of large positive number in the case of S3. So moving on, next, cross price elasticity of demand is when the percent change in quantity demanded of good, of something, of crackers, is divided by the percent change in the price of cookies. So if those two are related goods, then we would have a number that's different from 1, 0, from 1, right? So there's no from 0, because it can be 0. Suppose the percent change in the price of cookies is 10%, but the percent change in the quantity bought of diapers, something like that, completely unrelated, is 0, then those two are unrelated goods. So, but in case of substitutes, when the two goods are substitutes like cookies and crackers, we would have a positive number. So say the prices of cookies went up by 10%, then people want more crackers, if it's true that the two are substitutes. So we'll have a positive number for elasticity. A negative sign if the two goods are complements, so they're consumed together. Well, suppose cookies and jam are consumed together, right? They're probably not in the real life, but suppose they are. Then a percent, say 10% increase in the price of cookies will reduce the amount of jam you buy. So people want them together. So we'll have a negative elasticity, the cross price elasticity. Now, in this case, notice we do care about the sign. It gives us information. It tells us that the two goods are related. And independent is 0. Oh, cookies are increasing. Okay. The price of good B, that's an example, increases by 4%, causing the quantity demand of good A to decrease by 6%. So we need to compute the cross price elasticity of demand. So here, if we just answer the first one, we don't even have to answer the second one. So to decrease. So that is a negative sign. I want something increases, the other decreases. We already know the answer is negative. So quantity is on top, price is on the bottom of this fraction, right? So it's 6 divided by 4. And we have the number 1.5, and it's negative. The two goods are complements, and that's how you answer that question. Last elasticity, but then we will have a brief chat about taxes, which is important too. Sorry about kind of going slow today. So if your income goes up by 10%, everything that you will buy more of is called a normal good. So we can define it in terms of income elasticity of demand. So percent change in the quantity you buy of coffee, tea, wine, of pretty much most foods will increase and not decrease as your income will go up, as long as it's a normal good. So higher income leads to increase in quantity. Whereas for certain rare goods like ramen noodles and some used clothing, right? Your income goes up by 20%. Your consumption of those goods purchases will decrease, right? Those are called inferior goods. So these are the real definition of normal good and inferior goods. It's goods for which income elasticity is either positive or negative. And in fact, luxuries and necessities also have a definition in terms of income elasticity. Those normal goods for which income elasticity is higher than 1 are called luxuries. Okay, and those, like wine, vacation, everything, pretty much. And goods for which those normal goods for which income elasticity is between 0 and 1 are called necessities. So from now on, we're going to use this definition of necessity. So it's not something that you must have or necessarily need to buy, like bread and milk and eggs, but only those goods for which your income elasticity of demand is between 0 and 1. So as income increases by 10%, your purchases of these goods increases by less than 10%. So those are the ones that we call necessity. That's an economic definition. Bread is an example. So vacation and hamburgers. So maybe hamburgers under certain condition is actually an inferior good. Maybe as your income goes up, you'll tend to buy fewer Big Macs and eat more in a fancier place. So this example is how to find income elasticity. It's the same idea as any other elasticity. You look at the quantity change from 10 to 40, divide by the income change, percentage change in income. Okay. And in terms of income elasticity, we actually don't tend to use the midpoint formula. We use the regular formula because most often we know that income went up or went down. So unless specifically stated, to use midpoint, you can use a normal formula. I don't think you'll ever be confused with that. Oops, scary. So a quick detour into taxes, not a detour, but tour into taxes. Okay, when we talk about taxes, and then we'll connect it with elasticity and why it's important to actually put the two together. So when an economist analyzes taxes, what they do, they imagine that, say, the easiest way to look at it is as if a tax is imposed on a unit of per unit sales, sale of a good or a service. So once upon a time on this graph, something like, let's say, a fancy bottle of imported beer used to cost $3, right? $3 before tax, and 100 of those units were sold, 100,000 perhaps, in a certain location. And then all of a sudden, a 50-cent tax was imposed, saying we're not going to sell you beer or allow you to sell beer to the seller unless you pay a 50-cent tax. So the tax is really not paid directly by the buyer, even though the buyer is indirectly charged, but perhaps not even charged the entire amount. So part of the tax is most often borne by the seller and by the buyer too, but not necessarily in equal proportions. Not sometimes entirely by the seller, sometimes entirely by the buyer. And it has something to do with the elasticity of demand and supply. So the easiest way to draw that is as if the tax puts a wedge between the price that the buyer pays and the price that the seller receives. So this wedge between the two black dots on this graph, it is equals 50 cents. Okay, so it's as if the entire supply curve shifts up by 50 cents. So that's why we drew this second supply curve, which is red. It's higher by 50 cents. It went up. You can actually not draw that entire supply curve. You can just draw the wedge that the tax puts. And then this graph, we can compute. We can compute the amount of tax revenue. So at the new price, so now the new price that this seller receives is $2.80 and the buyer pays $3.30. And at that new price, less is sold. So 90 units are sold. So 45 times 50 is, for 90 times 50 cents is $45 is the amount of the tax that is collected. So it's that square area of 50 times 90. That's the tax. And yes, it reduces the amount sold. Sorry for that. In this case, also notice that buyers who used to pay $3 now pay $3.30. So they pay 30 cents out of 50 cents, right? Times 90 is the amount sold. So the burden for the buyers is $27. They pay that tax. And the sellers have a slightly smaller burden of $18 because they pay the 20% portion of the tax. What does it depend on the portion of the tax? Again, it depends on the shape of the curve. So it does relate to elasticity. I will give another example in a second. Okay, so in this example, the tax is on a hotel room of $100 a night as the tax. No, wait, the room rises. So the equilibrium price of the hotel room rises to $100 a night. It used to be $80. Okay, so once upon a time story is that the hotel room used to sell at $80 and 10,000 rooms were sold. And now that there's a tax, and how big is the tax? Can you tell me? You can already tell me from this graph without even drawing the wedge. You see where the supply curve starts at 40, right? And now it starts at 80, so it's a $40 tax. We know that. Now we could draw that. Let's see that in the wedge. So it's between the points A and B, that's the wedge. Between the price 60 that the sellers receive and 100 that the buyers pay. And here in this example, the buyers and sellers pay the same share of the tax, $20 each. Right? Because it used to be 80, now increased to 100, and you could sell by just this rectangles, the corresponding rectangles that show the burden of the tax on buyers, which is the top part of the tax rectangle. And then the bottom part is the portion that the sellers pay. Okay, so sometimes it's called excise tax because it's put onto a particular specific goods. Excise taxes, alcohol or cigarette taxes are called excise taxes. And yes, there are also taxes on hotel rooms too. And there's a reason why you don't want to put taxes on things like donuts or blue sweaters, because of the elasticity of demand and supply for those goods. So in another typical problem, you might be asked, so how high is the tax? Given this kind of picture, and you look at the points A and B, and you say, oh, the tax, that's easy. The tax is, what, 10, right? $10, because the price wedge is between 15 and 25 in this case. You can even compute how large the tax is, that 10 times 100 would be the area of that tax rectangle. So, okay, finally, our next point is that look at these two markets. In one market, so in both markets, supply curve is the same, identical, but in the first market, the demand curve is less elastic, right? More elastic is when it's flat, so less elastic. So buyers want something badly in the first market and not so badly in the second market. Oh, they have more choices in the second market. So, and you see that buyers end up paying more, a higher share of a similar tax in the first market. So whoever wants something bad enough will pay a higher share. So in the second market, it's the sellers whose elasticity of supply tends to be higher than even the buyers' elasticity of demand. So they end up, so the incidence of the tax falls more heavily on sellers in that case. So what the burden falls on the side of the market that is less elastic. Okay, I should skip that. This is a comparison with a relationship, that the tax, say in a long distance relationship, who will do more of the driving? Whoever demands that relationship more inelastically, right? So whoever is more committed, who loves more. Okay, elasticity of demand in relationship. Fine. All right, so increasing the tax rate. Okay, an interesting point, that increasing a tax rate does not necessarily increase tax revenue. So in this example, we have a tax rate of $20 per hotel room, and the tax revenue is 20 times 7,500 is 150,000. So that's the green area. And in that same market, we could put a 60 tax. So we could slap a $60 tax on that market. And that will really reduce the number of hotel guests that hotel is going to have. But it's not going to change their revenue, and it can actually reduce their revenue in some cases. So in this case, it really reduced the number of guests. And if you keep increasing the tax, you can probably totally eliminate that market and way reduce the tax revenue. So not always smart to make the tax large. And there are even stories of the unsuccessful taxes applied. So in this case of a luxury tax tax put on boats, recreational boats in 1919, 10% federal luxury tax, retail sale of luxury goods like pleasure boats with a sale price above 100,000. So on that tax projected a revenue of $9 billion. And in reality, people actually decided not to buy those boats. So massively decided not to buy that kind of boat. So maybe they went for cheaper boats, maybe boat prices that were right around 100,000, strategically decreased to, $99,000 $30,999. And so somehow 30,000 jobs were lost. I haven't read the story carefully, and I don't know in what industries the jobs were lost. Maybe the jobs are projected to increase in luxury, boat service industry, something like that. And then it ended up costing more in unemployment benefits. So the tax was repealed. Not a successful tax. Okay. That's the vote. So last point is that the tax generates deadweight loss. Remember that wedge that we saw in previous classes that generates deadweight loss. So we saw it with price controls, and that's the same here. So we have a market where consumer surplus and producer surplus shrinks. So now consumer surplus used to be that large triangle without the tax when 700 units were sold, and at the price of one, and now at the price of one, more like at the price of whatever the price is, like two, I suppose, in this case, $2 each. And now the consumer surplus shrinks, and so does the producer surplus. It also decreases, right? And by the amount of this tax rectangle, and the deadweight loss that used to be consumer and producer surplus, part of it just now becomes deadweight loss, becomes nothing, basically. Nobody gets that surplus. Government, yeah, taxes usually received by the government. Okay. For now, it's definitely the final point, is that, look at this graph, is the graph shows supply curve that's the same, but the demand curve is elastic in one case and inelastic in the other case. And look where, in which kind of market it would make more sense to slap the same tax on the first market or on the second market. Look, in the first market, where we have elastic demand, we have tax revenue that is smaller, and we have deadweight loss that is larger than in the second market with an elastic demand curve. And that means the tax is bad from social perspective. So we have smaller revenue, a larger deadweight loss. So the tax is really interrupting the normal functioning of the market, and it's disruptive. So we do not want to put a tax on a market where it would be very disruptive, unless we want to reduce demand. Okay, it also happens that, say, in the market for underage cigarette consumption, that you want to reduce demand. So maybe you do want to impose a tax like that. But again, you can argue that addicting goods have inelastic demand and all that. So a good tax would be imposed on a good with inelastic demand. So not on blue sweaters because they're green, and purple sweaters that are substitutes, but on things like alcohol in general, right? It doesn't have many substitutes. While beer, that's called Coors, has, or what is it called, Bud Light, right? Has substitute many other beers as substitutes, but alcohol in general doesn't. So you can put a tax on that, which it is. Put a tax.
Dr. Vernon, what if a nation, a country, was trying to reduce the consumption of imports to sort of balance their trade deficit? Like, would one of the tools they could use be to tax like imports or whatever?
Yeah, tariff, right? Yeah, right. Tariffs or quotas that I normally used to interrupt consumption. Yes, imports. So to disrupt markets for imports and reduce foreign. They also subsidies you could use for your own producers at home. You could pay them you know, $100 for every car sold. So they can be less efficient by $100 that way. Yeah, yes, so all taxes, all quotas, they do result in deadweight loss. Okay, but it's always a trade-off in economics. And like my last slide is going to be about the trade-off a little bit. But yeah, there's always a trade-off between like the goals you trying to achieve efficiency, but you may be unfair to, you know, foreign producers or to sometimes even domestic producers. Mm-hmm. So okay, so the same story about elasticity of supply. Like look, in this graph we have demand curves that are the same, but supply is more elastic in the first one and less elastic in the second graph. And we also have a tax that results in higher deadweight loss in case of a more elastic supply. So again, a better tax is put in the second case, with case D in this case, where we have less elastic demand and supply. So ideal tax is put on a market with inelastic supply and demand, where the market is not going to be affected that much. So yeah, but unfortunately, this kind of market can be a market for insulin. Right? Very, very inelastic demand. Right? Maybe not super elastic supply too, given the monopolies, you can control it. So you can put a tax and it will have a small deadweight loss, but is it going to be fair? Right? So you're going to have people who have diabetes and who are struggling, but they're alive, pay higher prices. So probably not super fair, right? So there should be other considerations involved. Yeah, ideally you want those who benefit from public spending, they should bear the burden of the tax that pays for that spending. How do you do that though? It's not even practical. Maybe when people are young, they should pay a tax and then to finance their own insurance in the time when they really need some public assistance. Maybe those who who grew with greater abilities to pay a tax should pay more tax. That sounds fair, right? So with greater ability to pay a tax, so the richer should pay more tax and maybe more higher rate of tax. So that illustrates the trade-off between equity and efficiency. Yes, fairness and efficiency too. Okay, questions about this? Any questions? That was a lot of information. Sorry, I went over time. I won't do it anymore. I'll be more careful next time.